the concept of activity and its calculations. So in the previous slides we have seen fugacity. Fugacity is a effective pressure of a compound in a mixture. Activity is a effective compound in a non-ideal mixture. So there is a relationship between the activity and fugacity. That is, the activity of any compound, AI is equal to the fugacity of a compound at a standard state. Okay, ideal gas mixtures. This AI is equal to, we can write this, we already know. Ideal gas mixtures we already know. Fugacity of a compound is equal to mole fraction into pure compound fugacity by Fi standard. And this Yi into Fi by the Fi here stands for fugacity of a compound in a pure state. Fi naught stands for fugacity of a compound at standard state. So generally standard state means generally any particular if you take any compound, generally in a standard state, like 1 atmosphere pressure and room temperature, what is the state of that compound? Generally, for example, water is in a liquid state, that is standard state of a liquid. Like oxygen, for example, that is in a at 1 atmospheric pressure and room temperature. At room temperature, the oxygen is in a gas state, that is a standard state. So here the Fi stands for the pure means when it is in a single state, what is the fugacity of that particular compound? Fi naught stands for at a standard state, what is the fugacity of a compound? Okay, so generally pure state Fi naught also can be written as Fi also, because pure compound standard state equal to pure compound fugacity is equal to standard state fugacity. Okay, so that both will get cancelled. We will get AI is equal to AI is equal to Yi. So we already seen now here we derived how we got the activity is equal to mole fraction. In the same way, pure liquids, ideal liquids, AI is equal to generally formula Fi bar by Fi standard. Okay, so we can write Xi into Fi by Fi standard. So I already said that Xi into Fi by Fi standard can be write as a Fi pure. Okay, now both are get cancelled, we will get the Xi. So AI is equal to Xi, means mole activity of a compound is equal to mole fraction for ideal liquids. Next, whereas for non-ideal gas mixtures, there is a activity coefficient, that is for gases AI is equal to pi I bar I into Yi. For liquids, AI is equal to gamma I into Xi. So here the pi I bar and gamma I are the activity coefficient for of ideal gases and liquids respectively. Next one is the ideal and non-ideal solutions. So what is ideal solutions? When the compound is in a pure state, whatever the property it is having, when same compound, when it is in a mixture, so same properties it is maintaining. So then it is called, that's the ideal compound. In other words, in a mixture, if means when at the pure state, the properties When they are equal to, when even though the component is in mixture state, because there are no interaction between the compounds. So that is means in the then only the properties of a compound in a pure state, the properties of a compound in a mixture state, both are equal. So the when we call any compound in ideal, it is behaving as ideal, means the properties of a compound in a pure state, and which are equal to the properties of a compound in a mixture. Okay, so that is a ideal behavior of a compound. So in other words, total volume, generally we have seen molar property, total molar property is equal to summation of xi into mi bar. We have already seen. So this is equal to this summation of xi into bar is equal to partial molar property of a compound in a mixture. So xi into mi bar. Mi means the here mi stands for the partial molar property of a compound in a pure state. Okay, so when if it is equal, like then mi bar is equal to mi, then is equal to then that compound behaving as a ideal. Okay. Okay, so in a here in a volume point of view, it is explained. So look at total volume is equal to summation of xi into vi bar. Okay, so summation of xi is equal to, so there is no volume the volume of the partial volume of a compound in a mixture is equal to molar volume of a compound. So if it is equal, that is called ideal liquid. There are some laws which are explains the properties of a mixtures. So in that Lewis-Randall rule, it says that the fugacity of each constant is directly proportional to the number of moles of the constant in a solution. Each compound fugacity is directly proportional to mole fraction of a constant in a solution. Means each compound fugacity is directly proportional to mole fraction of a compound in a solution. Otherwise, Fi bar is equal to xi into Fi. Fi stands for here the pure compound fugacity. A fugacity of a compound I in the pure state. So generally, this Lewis-Randall rule is applicable to all gas mixtures for moderate temperature and pressures. Whereas a few mixtures only follow the above rule. This Lewis-Randall rule is follows only few liquid mixtures, but whereas all gas mixtures will follow that rule at moderate temperature and pressures. For example, same isotherms like ardo, meta, parax, these type of compound, when they form a mixture, then they will follow that Lewis-Randall rule. Adjacent members of homogeneous series of organic compounds, for example, hexane, henaptane, when they form a mixture, then they also follow the Lewis-Randall rule. And for example, other example, ethanol, propanol, benzene, toluene, ethylene bromide, and ethylene iodide. Like type of chemicals, when they mix and form a mixture, so these mixtures behave as ideal solutions and follow the Lewis-Randall rule. Next one is the Raoult's law. Raoult's law explains the liquid vapor equilibrium. So when the vapor and when the liquid and vapor both are in equilibrium, in that state, the partial pressure of a constituent is directly proportional to the mole fraction of a compound in a solution. So this is called Raoult's law. When the liquid state and vapor state both are in equilibrium, the partial pressure of a compound is directly proportional to mole fraction of a compound in the liquid state, because the liquid and gas both are in equilibrium. The partial pressure of a compound is directly proportional to mole fraction of a compound in a solution, liquid solution. So this we can write Pi is equal to Xi into Pi saturated pressure. Ideal solutions which conform to Raoult's law over the entire range of concentration are rare. Okay, so means entire range of concentrations follow the Raoult's law. It is rare. So example for ideal solution frequently cited: optical isomers, organic compounds. They behave as a optical isomers. They behave as a ideal solutions, and they satisfy the Raoult's law. Next, Henry's law. For example, many in a solution of whose components does not obey the Raoult's law is designated as non-ideal solution. For example, which are the mixture are not following the Raoult's law, they are considered as a non-ideal solutions. So for that the Henry's law is explained to determine the properties of a non-ideal solution. That is, fugacity of a compound is directly proportional to the concentration in the liquid. Okay, the fugacity of a compound is directly proportional to concentration of a compound with a Henry's constant. So otherwise, for liquids, partial pressure is equal to Xi into K. K is a Henry's constant. The Henry's law deviate for all solution where the solute mole fraction if the solute mole fraction in the mixture greater than 0.1, then the solution may deviate from the Henry's law. Next one is the Gibbs Duhem equation. So the Gibbs Duhem equation, now up to now we have seen in a solution what is the partial molar property of a compound. Now the Gibbs Duhem equation explains, is there any correlation between these partial molar properties of a different compounds? In a mixture, there are different compounds are there. So the compounds properties are called partial molar properties. Is there any relation or correlation between these partial molar properties in that between different compounds? So that equation is called Gibbs Duhem equation. We already know that total change of molar property is equal to, at constant temperature and pressure, is equal to summation of mi bar into dni. Okay, so when you integrate it, we get the mt is equal to summation of mi at constant temperature and pressure, mi into ni, mi bar into ni. Okay, so we already know this one. Now apply the derivation to this expression both sides. Okay, when you apply that, dmt at constant temperature and pressure is equal to first term into second term derivation. This is the first term, this is the second term. First term into second term derivation plus summation, second term into first term derivation dmi bar. Okay, we got this. After that, we already know that dmt is equal to summation of mi bar into dni. So substitute this one in the above expression. The above expression is this. This is the summation mi bar into dni is equal to summation mi bar dni plus summation ni into dmi bar. Okay. So bring this term to that side. So then we will get 0 is equal to summation mi bar dni. So this minus will get plus summation mi bar dni plus summation ni into dmi bar. Okay, so this is a minus, this is a plus, both are get cancelled. So summation of ni into dmi bar is equal to 0. Okay, so this is called general form of, this is called now, so summation ni into dmi bar is equal to 0. So this is called general form of Gibbs Duhem's equation. Now what is the meaning of this? Change of molar properties. Change of molar property of a particular compound when you remove the summation n1 plus dm2 bar n2 plus dm3 bar n3 so on is equal to 0. Means the change of molar property in the summation of change of molar property of a particular compound and its multiplication of its number of moles, total summation is equal to 0. This is Gibbs Duhem. This is the relationship between the partial molar properties of a compound in a mixture. So from this we can understand how the compounds which are there in the mixture, they are correlated with one another. How they are correlated? The summation of all the change of molar properties of all the compounds, multiplication with the their total number of moles, that summation, total summation is equal to 0. That way they are correlated. Next one is the property change of mixing. So, what is the meaning of this? Property change of mixing means for ideal solution, the total molar property is equal to sum of partial molar property of a constant. We have already seen that. This is okay. For ideal solution, so means what is the meaning of this? The property change of mixing. For example, in a beaker, number of compounds are there, the compound mixture is there. In that, a particular compound, like a first compound, some amount of number of moles of compound is added to that. When you mix it, what is the property change? When you mix a one particular compound, what is the change? What is the change? What is the delta that change? Initially, some property is there. Before adding, after adding, something is there. What is that change? Or before that, one property is there. So you remove, not adding, you remove it. Then what is the property change? What is that change? So this property change of mixing explains when you add or remove particular compound to a mixture, what is the change in that property? Those are total change in property. So we know already total mt is equal to it came from the, we already know total dmt. It came from the dmt is equal to dmt is equal to summation mi bar into dni. So when you integrate the both side, mt is equal to summation mi into ni. This is mt is equal to summation mi into xi into number of moles are there into capital N is it. So because of that, this is total MT is the total number of moles into N into capital M. N into capital M. So summation Mi. This is bar is it. Bar. Mi bar into Xi. So by N is it. This N will get cancelled. Now M is equal to summation Mi bar into Xi. Okay. So here this is. Okay. This M represents the molar property. This is not total. Molar properties of a solution. Molar property of a solution is equal to summation of Mi bar into Xi. So for ideal solution, for ideal mixture, M is equal to summation of Mi bar, summation of Mi into Xi, because partial for ideal mixture, partial molar property is equal to pure compound molar property. Okay, so that's way. So we got this one. M is equal to summation of Xi into Mi. Okay, but even though for ideal solution it may not exactly correct. What is the meaning of that? What is the means the molar property of a solution is a summation of individual molar properties of a compounds multiplied with the mole fractions. But if for ideal solutions also, it is exactly not true. So that's the reason. So one more term is added, that is delta M. Means delta M is a property change of mixing. So when you add or remove, what is the change of that property? Okay. So from there, so initially we got M is equal to summation Xi into Mi. So we added another term because even though for ideal solution is not true, that's the reason. So now from here, you bring this term to this side, left hand side. Now a plus is there. When you come to left hand side, summation minus will come. Summation Xi into Mi is equal to delta M. So in other words, delta M is equal to M in minus summation Xi Mi. For more general definition, this delta M can be written as delta M is equal to M minus summation Xi into Mi standard. Okay. This M we know, delta M is equal to M we already know. Initially M is equal to, we have written summation of Mi into Xi. Okay. So now, so summation of Xi into Mi minus summation of Xi into Mi standard. So delta M is equal to summation Xi when you bring the common Mi minus Mi standard. Okay. Mi minus Mi bar is there, no? Okay. Bar. Okay. This means the total, the property change, the delta means property change of mixing. The property change of mixing, summation of partial molar property of a compound minus standard molar property of that compound. When you are subtracted and multiplied with the that particular compound mole fraction, that's total summation is the change property, means how much property changed because of mixing or deletion. Okay. So here Mi bar mi bar minus mi o naught can be treated as the change in the property of components in I when 1 mole of pure I in its standard state is brought to the given composition at the same temperature and pressure. Next one, excess property. So what is the excess property? Okay, property of a real solution and property of ideal solution very important in a pharmaceutical industry. In a pharmaceutical industry especially, we need what is the ideal solution, ideal mixtures property and real mixtures property to determine many things. So that's the reason the another thermodynamic property is defined and added, that is Me stands for the excess property. It's defined as the difference between the real ideal minus real, nothing else. Okay, the Me is the excess property, is difference between the what is the real property of a what is the property of a real compound, but when we assume that it is the ideal state, what is that? The subtraction of both, the difference between the both is called excess property. Means that much is for example, in this case, for example, the real compound, the real when it is in the compound, when it is in a real state, the M means the property behaving as a ideally, then M both are equal, then there is no M is equal to 0, there is no excess property. Means in other words, it is telling how much it is deviating from the ideal behavior. Okay. So this is excess property. So Me is equal to M minus M ideal. So multiply difference for all the sides. So then delta Me, change of excess property, is equal to change of molar property, change of property of in a real state, property change of property in a ideal state. Okay, now but we know already, now we will define what this one and we will this one. We already know delta M is equal to from the property change of mixing M minus summation Xi into Mi standard. So in the same way, Mi ideal is equal to M ideal minus summation Xi into Mi standard. Okay. So now substitute them in the above equation. Delta M E is equal to, so this one is this one. So M minus summation Xi Mi standard minus M ideal minus summation Xi to Mi naught. Okay. So this is minus, this will be plus, means delta Me is equal to M minus summation Xi Mi standard minus, when you multiply the minus into the bracket, M ideal minus into minus plus, so summation Xi Mi ideal. Okay, this one both get cancelled. Now we will get the delta Me, change of excess property, is equal to M minus M ideal. But we know already M minus ideal is equal to M E. Okay, so means the change of excess property is nothing but excess property. What is the change of excess property? That is equal to the excess property of a mixture. Okay, so these are some problems we will discuss. So with this, the third unit outcome is the understand to determine thermodynamic liquid properties. Now we have seen the liquid properties are means what is the partial molar property of a compound. Now after what is the physical meaning of that, then what is the total molar property of a solution. After that chemical, what is the chemical potential. Next what is the chemical potential. Then after that, what is the fugacity, what is the concept of activity, what is the excess property, what is the property change of mixing. So and what is the ideal solution, non-ideal solution, that we have seen. So from there we can so from using these concept we can determine the liquid property, liquid state, liquid thermodynamic properties by using the whatever discussion. Okay, so by so the outcome of this is, after completion of this, you are a student able to understand how to determine the thermodynamic properties of a liquid mixtures. Okay, thank you.
Like, share and subscribe. Hit the bell icon for more updates.